absent and you need help because you weren't here when we talked about how to do this in your packet. And then other folks were here and you just need a little bit more support in order to be able to do this. Now, recall, this is information that's going to be really elaborated and introduced on in your freshman year at the high school. But we're doing it here at the end of 8th grade to kind of give you a jump start on this, because this material provides the backbone of about 5 to 6 chapters of material next year. So you're going to be building upon this. So the first thing that we do is we make sure that we understand that this is the periodic table of elements, and it uses symbols, and you guys have already memorized a lot of these symbols. It uses symbols on here to say what the elements are. So capital H, this is hydrogen. Now there's 2 numbers on here. The first number right here up at the top, the whole number, that's the one that we're going to focus on. This is the atomic number. So you can see here for beryllium, I circled the atomic number because, and again, if you look over here, there's a key, and this tells you that this is the atomic number. The atomic number always equals the number of protons. It's just fact. You got to get that in your head. Atomic number equals protons. So when we look at this paper and we have to fill in the number of protons, all we have to do is look at the periodic table and record the atomic number. So hydrogen's atomic number is 1. That means it has 1 proton. Helium's atomic number is 2. That means helium has 2 protons. Lithium's atomic number is 3. That means lithium has 3 protons. If you look at beryllium, the atomic number is 4, so it has 4 protons. Boron, the atomic number 5, that means it has 5 protons. So this column is so easy to fill in because you just look at the periodic table and it's the atomic number. If we were to fill in electrons, this one is also easy. So protons, you should have memorized by now, but protons have a positive charge and the electrons have a negative charge. The number of positive protons will always cancel out the number of negative electrons. So those 2 columns are always equal. So if there's 1 positive, there's 1 negative. If there's 2 positives, there's 2 negatives. If there's 3 positives, there's 3 negatives. So protons and neutrons should always equal each other. Now, neutrons, you do have to do a little bit more work to figure those out. And this is something, you know this because I'm telling this to you. This number right here is the mass number. Whenever you see the name of an element with a dash and a number written after it, that's the mass number. The mass number equals the protons and the neutrons added up. Now we've talked about why. Atoms are made of protons, electrons, neutrons, and empty space. Well, empty space doesn't have any mass. Electrons, remember, these are super tiny, so we don't even bother. That's why the mass is only the protons and the neutrons added together. Now, if I look, hydrogen has 1 proton. How many neutrons would give me a mass of 1? Well, 0. 1 proton plus 0 neutrons would equal 1. Mass number is 4 for helium. I already know I have 2 protons, so the question is, how many neutrons would equal this mass of 4? 2 protons plus 2 neutrons. 3 protons plus 4 neutrons would give me a mass of 7. 4 protons plus 5 neutrons would give me a mass of 9. 5 protons plus 6 neutrons would give me a mass of 11. All right, so electron cloud diagrams. Well, actually, before we even do electron cloud diagrams, let's go through and do the next page and fill this in. Carbon, atomic number 6, 6 protons. Nitrogen, atomic number 7, 7 protons. I could keep going. Oxygen, atomic number 8, 8 protons. Fluorine, 9 protons. Neon, 10 protons. And sodium, 11 protons. Protons and electrons always equal each other. Neutrons, I have to do a little bit more work. Okay, remember, this is the mass number. That's the protons and neutrons added together. 6 protons plus 6 neutrons would give me a mass of 12. 7 protons and 7 neutrons would give me a mass of 14. 8 protons plus 8 neutrons would give me a mass of 16. 9 protons plus 10 neutrons would give me a mass of 19. 10 protons, 10 neutrons would give me a mass of 20. 11 protons and 12 neutrons would give me a mass of 23. All right, so now let's go back and do electron cloud diagrams. Okay, for electron cloud diagrams, we are only going to focus on the electrons. If you were absent when we talked about this, we talked about electrons are in energy levels. The first energy level can hold 2 electrons. There's a little 2. After that, every additional energy level can hold 8 electrons. All right, so 1 electron. I'm going to draw 1 energy level. There's 1 electron there, and I'm done. Let's not worry about this just yet. Helium has 2 electrons. I draw an energy level. The first level can hold 2 electrons. It has 2 electrons. I'm done. Lithium, 3 electrons. I draw the first electron or first energy level and I put 2 electrons in it. But remember, that energy level becomes full once you have 2. So I have to add an additional energy level and put that third electron there. Beryllium has 4 electrons. 2 in the first, 2 in the second. Once the first level was filled with 2, it couldn't hold any more. Boron has 5 electrons. 2 in the first, 3 in the second. Now we're going to talk about this, what it'll do to become stable. Now, a stable element is one where its outer energy level is completely filled with electrons. So let me start down here at boron. This is its outer energy level. It has 3, but remember, that level can actually hold 8 electrons, so that is not filled, so it is not stable. So boron can do one of 2 things. It needs to have 8 electrons in this level for it to be full. It could go 1, 2, 3, 4, 5. Let me find 5 more electrons to add into that. So, or it could remove these 3 electrons. Now this is its last level, and that last level can hold 2 electrons, so that would be full. So boron will lose 3 electrons, and I want you to write it like that. I don't want you to say minus 3 electrons. I want you to say lose 3 electrons, and you can abbreviate electrons. Boron has 2 in this energy level. It needs 8, so it could add 6, or it could just remove these 2. Now that's its last energy level, and that's filled. So it'll lose 2 electrons. Lithium needs 8 in this level. It could gain 7, or it could just lose this one. And if it loses this one, now that's its last level. That level, the first level, can only hold 2 electrons, so that's full. So this one will lose 1 electron. If you look, helium has 1 energy level and it's got 2 electrons in it. Well, that first energy level can hold 2 electrons, so that is filled. So that means that helium is stable. So what will it do to become stable? Nothing. It already is stable. Hydrogen, let's just skip hydrogen because it's a weird one. All right, so now let me say what charge it will have. Well, if we look here, helium started out neutral. It had 2 positives and 2 negatives. Well, it's not going to do anything. It's not going to lose or gain electrons, so its charge is still neutral, so I'll just put 0. Now, lithium started out with 3 positives and 3 negatives. I'm going to write that off to the side. To become stable, atoms can only move electrons around. So if it started with 3 protons and 3 electrons, it's going to lose an electron. So now, instead of having 3 electrons, it's going to have 2 electrons. Well, I can see that that's not neutral anymore. That's going to cancel out, or not cancel out. And when you have opposite charges, you subtract your numbers. 3 minus 2 is 1. But then when I look, there's more positives than negatives, so it's going to have a 1 plus charge. Boron started out with 4 positives and 4 negatives. But according to this, we said to become stable, it's going to lose 2 electrons. So if I do my math here, there's going to be an extra 2 plus charge now. Boron started out with 5 positives and 5 negatives. You told me it's going to lose 3 negative charges, so now it'll have a total 2 minus after it's lost 3 negative charges. Now it's got a charge of 3 plus. So if that doesn't really make sense, take a minute to go back and just think about it. I know you can figure that out. So kind of pause the video and go back and reflect and see if you can't figure out why that's a 3 plus charge. All right, so let's draw the electron cloud diagrams for these. Okay, remember, electrons, we're only focusing on this number. Carbon has 2 electrons in the first level, has 6 total, so there must be 4 in the second level. If you add that all up, there's 6. Nitrogen, 2 in the first, 5 in the second. That equals 7, right? First energy level's full at 2, so then I got to move to the next one. Oxygen has 2 electrons in the first, 6 in the second. That's 8 total. Fluorine, 2 in the first, 7 in the second, that equals 9. Sodium, 2 in the first, 8 in the second, that equals 10. And finally sodium, 2 in the first, 8 in the second. The second level can only hold 8 electrons. Right now I only have 10. So for that 11th electron, I've got to build another energy level and I've got to put that in there. So carbon, right, it needs to have 8 electrons in this last level. It only has 4. It's halfway there. And I don't know whether at this point we're just going to say it's halfway there. It might lose 4 electrons. It might gain 4 electrons. I'm not really sure at this point. There'll be explanations for that more next year. So then I would go, if it loses 4 electrons, it'll have a 4 positive charge. If it gains 4 electrons, it'll have a 4 minus charge. Remember, electrons will always do whatever's the smallest number. So I don't know out of these two which it's going to do. Nitrogen has 1, 2, 3, 4, 5 electrons there. If it could just add 3 more, 1, 2, 3, it would have 8 electrons there. Or it could get rid of 5. Remember, it's always going to do the smallest number. So it's going to gain 3 electrons. I do not want you to say plus 3 electrons. Do not do that. Actually write it out. Gain 3 electrons. Oxygen has 6 there. It needs 8 in that level. It's just easier to gain 2 electrons to get to 8. Fluorine has 1, 2, 3, 4, 5, 6, 7 electrons. It only needs 1 more. It's going to gain 1 electron. Neon has 8 electrons in the last level. That's what it needs. It's stable. It's going to do nothing to become stable because it already is stable. Sodium has 1 electron in the last level. It can gain 7 to have 8 there. Or it could get rid of this one. Now this is its last energy level and that's filled. So it'll do the easier one, the smaller one, lose 1 electron. Now I'm going to go back and I'm going to fill in charges. Right? Nitrogen started with 7 positives and 7 negatives. According to this, we said to become stable, it's going to gain 3 extra negative charges. So if I gain 3 extra negative charges, I don't have 7 anymore. I have 10. 10 minus 7 is 3, and I can see that I have more negatives, so that it ends up that nitrogen has a 3 minus charge. Oxygen starts out with 8 positives and 8 negatives. If it gains 2 negative charges to become stable, it'll have 10 negative charges. That'll give it a charge of 2 minus. 9 positives, 9 negatives is what fluorine started out with. If it gains an electron to become stable, that'll be 10 negative charges. That will leave over a 1 negative charge. This doesn't do anything, so it's neutral. Sodium started with 11 positives and 11 negatives. If it loses an electron, it will now have 10. That leaves it with a charge of 1 plus now. What I would recommend is that you take a minute and pause the video and see if you can't fill in these columns. And then unpause the video and I'll have the answers. Okay, so I'm not going to explain how I got those numbers anymore because, right, went through a lengthy explanation on the last 2 pages. So if you're still not sure how to get these numbers, you need to go back and rewind the video and watch my explanation of how to get those. Now I would recommend that you pause the video and do all the electron cloud diagrams for these elements and unpause the video once you've done that to check your answers. 12. 2 in the first level, 8 in the second, 2 in the third. That means 12 electrons total. Aluminum, 13 electrons, 2 in the first, 8 in the second, 3 in the third. Silicon, 14 electrons, 2 in the first, 8 in the second, 4 in the third. That equals 14. Phosphorus, 2 in the first, 8 in the second, 5 in the third for 15. Sulfur, 2, 8, 6 for 16. All right, so now you've seen that those are the answers. I would take a minute and I would pause the video and I would try to fill in this column. Then unpause the video when you're done to check your answers. Magnesium needs 8 valence electrons in the last level. It could either add 6 to get to 8 or it could remove 2. Removing 2 is the smaller number. So it's going to lose 2 electrons. Aluminum will lose 3 electrons to become stable. Oh, silicon is halfway there. It could either lose 4 or share or gain 4. I'll put both. Sulfur, 1, 2, 3, 4, 5 electrons. It could lose 5 or gain 3. It's easier to gain 3 to get up to 8. This has 6 in its outer energy level, so it'll gain 2 electrons to become stable. All right, so now I would pause the video again and I would see if you could guess the charges. When you are done, unpause the video and look at my answers. So magnesium started with 12 positives and 12 negatives. According to this, you told me we said it's going to lose 2 electrons. That'll be a 2 plus charge. Aluminum started with 13 positives and 13 negatives. According to this, it's going to lose 3 negatives, so that'll be a 3 plus charge. If it loses 4, it'll become 4 positive. If it gains 4, it'll become 4 negative. Phosphorus started with 15 positives and 15 negatives. If it gains 3 negative charges to become stable, now has a 3 minus charge. Sulfur started with 16 positives and 16 negatives. If it gains 2 electrons, this will change to 8, and it'll have a 2 minus charge. All right, so this is your last page. I would pause and see if you can fill in these 3 columns. All right, so that's the answers to the first 3 columns. I would pause and do your electron cloud diagrams, and then restart so that you can see if you did them right. Okay, 17 electrons. 2 in the first, 8 in the second, and 7 in the third. Argon, 2 in the first, 3, 4, 5, 6, 7, 8 in the second, 8 in the third. Potassium, 2 in the first, 8 in the second, 8 in the third. Now, right now, I have 18 electrons there, but I need 19. Remember, this one's filled at 8, so I need to move to the third level and add one more to get to 19. Calcium, 2 in the first, 8 in the second, 8 in the third, and I need 2 more to get to 20. All right, so now I pause and then see if you can get this column, what it'll do to become stable. So this has 7, 1, 2, 3, 4, 5, 6, 7. Oh, it only needs one more, so it's going to gain 1 electron. This has 8 electrons in its last level. That makes it stable, so it's not going to do anything to become stable. And it'll keep the same number of protons and electrons, so it'll have no charge. Potassium will lose 1 electron, and calcium will lose 2 electrons. All right, so then if I gain 1 electron, right, I will pause and see if you can get these charges right now. 17 positive electrons, 17 negative electrons. If I gain 1 electron, I will now have a 1 minus charge. Potassium started with 19 positives and 19 negatives. If you lose an electron, that goes down to 18. Now you have a 1 positive charge. Calcium has 20 positives and 20 negatives. It's going to lose 2 electrons to have a 2 plus charge. All right, so again, if there's any part where you're like, I still don't really understand this column, you need to rewind back to the beginning and watch the first 2 pages, because that's when I explained how to find all of that. This is done in class tomorrow. You need to make sure you turn it in before the test.